Morning, Simaj. I am Madhav from BCA AKU Batch-1 second semester, and today I am here to solve a question on optimal page replacement policy that comes under the head of page replacement algorithm. So, here is the reference string that is given 701203042303212071, and we take frame size as 4. So, we make this box as frame 1, frame 2, frame 3, frame 4 because we have given the frame size is 4. So at first there all the memory are empty. So we have to call it from hard disk. So at first we have to call 7. So we call 7, and then we have to call 0. Then we have to call 1. Then we have to, in all these 4 we have page fault because it is not already present in the memory. We have to call it from hard disk, and in this 7012 we have already seen that here the reference string is 0 and in memory 0 is present. So in this no page fault occurs. Similarly, in the next, here we see that we have to put 3, but there is no 3 in the box, so we have to call 3. So optimal page replacement policy is that we have to call it from the right side. So if the further we see that how much late the number comes. So we check 2107. We have to check 2107 from the further reference string. We see that there is 0. We have 0 here. 4. There is no 4 in this box, so we have to leave it 2, and we have to find 1. 1 is here, so at last we see 7. 7 at last, so we have to replace 7 with 3. Now we see that 0 is present in this memory, so in this no page fault occurs. Similarly, in the next we see that we have to call 4 from the reference string, but there is no 4 present in the memory, so we have to call it from the with the help of optimal page replacement policy. So we see further the 2103. So here is 2 present near to this box. Then we see that 0, it is also present here, 3, and at last the further is 1. So we have to replace 1 with 4. Now, so in this we have already 2, so there is no page fault occurs. Similarly, in the next question, next memory table, we have reference string 3, and we have already 3 is already present in the box. So in this there is no page fault occurs. Similarly, in the next we have to find 0 in the memory, and 0 is already present, so there is no page fault occurs in this. In the next memory we have to find 3, and there is 3 already present in the memory, so in this also no page fault occurs. In the next table we have reference string 2, and in memory there is 2 already present in this, so in this also there is no page fault occurs. In the next there is 2403, but we have to replace it by 1. We see the further, and the string which is already present in the memory, we have checked the later which string comes later. So we have seen 2. 2 is just beside our memory, and then 0. 0 is also present just beside our memory, and we have 3 and 4. There is no 3 and 4, so we replace any one of them. So we replace 3, 0. Oh, sorry. In this we have to replace. So we replace 1, 3 with 1. In next 1, 0, 4, 2. In this 2 is already present in this box, so there is no page fault occurred. In the next memory allocation, we have already 0 present in the memory, so in this also there is no page fault occurred. Now in the next we have to put 7 in the memory, but there is no 7 present in our memory, so we have to call 7. We see further reference string that is 0 and 1. 0 and 1 is present in our memory, so we do not call this reference string. we have to call 2 and 4. We can replace any one of them. So we replace in this we replace 4 with 7. So there in this 7 2. In this 0 is already present in the box, so there is no page fault occur. And at last we have reference string 1, and 1 is already present in the memory, so there is no page fault occur. So there is total 1, 2, 3, 4, 5, 6, 7, 8. So we have total 8 page fault present in this question. That's all from my side. Thank you.